on this note, we are actually now moving from AI, but it still stays somewhere close to it because we're going to talk about Apple, NVIDIA, and much more. So we have two fantastic engineers who are talking about the insights from working in these big technology companies. And they are...
We will be joined by Karlis Broders, who's the co-founder and CTO at Trace.Space, and Gints Klimanis, computer engineer as well, on the
let's
stage.
welcome both.
Welcome to both.
Hello.
Sveiki, sveiki.
Thank you for coming out. I mean, the light isn't as bad as the previous speakers told me. I can still see you. Anyway, Gint, I want to start with, obviously, you know, two of the world's biggest companies, NVIDIA and Apple. We want to talk about that. But I want to take a step back and talk about actually another really big company called IBM, and your father working there, and other Latvians actually working there at IBM, and that being a source of inspiration for you to pursue a career in engineering.
Yeah. Okay. Sveiki. Hello. Since that's the starting topic, I suppose we can begin with my grandparents were World War II refugees from Latvia. There was an obvious talent drain from the Baltic states. And they fled through Germany, ended up in New York with, well, they were in refugee camps in Germany for a while, and ended up in New York. My father didn't speak a word of English at the time, at age 13, but they managed to learn it in a year. And a number of other Latvians had the ability to learn the language very quickly, and just advanced in mathematics. At IBM, maybe in these circles, is known, but outside, it's a company that lost its technological edge. But 30 plus years ago, it was the defining technology company. In New York, where a number of the Latvians clustered in the Latvian community in America in New York City. We had a Latvian school. We were shuttled there every Saturday to learn Latvian. Jā, es mazliet runāju latviski, bet mans līmenis ir samērā zemi. And my father and roughly 7, maybe a little bit more. I can name 7 Latvians that worked at IBM. My father worked at East Fishkill, designing the world's fastest and smallest memory circuits at the time. That was the global premier semiconductor manufacturing facility. It still exists, but is not in the league of Taiwan Semiconductor Manufacturing Corporation. Another Latvian, Andris Padiks, was a CPU architect on the IBM 360, defining much of computer architecture, massively parallel systems, and whatnot. And there were others, Jānis Zārds, Jānis Ciguzis, and we all knew each other in that area. I would say, as a result of my father, I'm not an orthopedic surgeon. As a youth, I fought and broke a lot of fingers. That would be a natural career path for me. But I followed in my father's footsteps as an electrical engineer. Made it to Cornell University, studied computer engineering there with an emphasis on signal processing and parallel computing. As a result of that choice in university, I had a lot of job opportunities, and I took the one that led me to California, Silicon Valley. Yes.
All right, so right away you get, it's year 2000, and you're working at NVIDIA. Could you tell a little bit of why NVIDIA, as like we all know NVIDIA's GPUs, and why does it matter for GPU to have somebody who works with audio and digital signal processing?
Well, I have to understand that NVIDIA isn't really an AI company. It's a computing acceleration company. From the beginning, it found a niche in graphics, spread out to other acceleration, video acceleration, audio acceleration. That's where I had my start. the company moved into cryptography for a while with crypto mining. There was a boom there, and now there's the AI boom. There will be others, but really what the company is about is massive parallelization at the microscale, the holy grail of computer code being the complete parallelization of serial code. At the beginning, really, it was about keeping the company in business. As Jensen, there were 300 people, 200, 300, 400 people at the time. So it's not like you don't see these people every day. He was famous for saying the company was 30 days away from going out of business, and that was really if they didn't make this contract, didn't sell these particular audio, video, multimedia accelerator chipsets and graphic chipsets, the company wouldn't exist anymore.
So now they are literally the biggest company in the world, and something that you told me backstage was fascinating to me, that already in early 2000s, you as a company, you understood that this someday will be used for AI.
It's an acceleration company looking for an application, simulating the brain. At that time, nobody could predict when it would occur. It's inevitable it would occur at some point. And we have surprises every few years, and even last week with DeepSeek, how rapidly that moves along. So it's very difficult to predict the evolution of computing power in that sense. But the framework was set up 20 years ago with the initial design of CUDA, launching a software effort, and part of the skill of the company was also not falling into the trap of, say, trying to make a few cents per chip in mobile phones with a small chip. Right? They held their course, adding as many cores as possible, trying to get the yields up, trying to control temperature, control power, and set up a software system, acquiring larger systems to move from just one graphics chip to bonding two chips together, to building complex systems with 72 dual GPUs that you can buy today, to roomfuls of these things. So it's an acceleration company, and that's the way to look at it. Much in the way you look at Tesla. Tesla is a well-diversified index fund. Not a car company. So it was in the energy business. It's in the energy time-shifting business. It's in the robotics business. But fundamentally, if you look at what it makes, it's making factories. We just don't realize it yet.
So, like even Tesla's engineering headquarters is in I think in Palo Alto now, in the Bay Area, and Silicon Valley. Can you talk about that? You grew up in the state of New York, went to school there, went to Cornell University there. What was the move like, and what was life like in Silicon Valley among all these companies? And could you talk a little bit about that?
The transition there was easy. They just gave me a plane ticket, and I didn't have anything to move, so I just hopped on and was situated there immediately at a company called Silicon Graphics, from which many people went on to work at all the other companies, most notably AMD and NVIDIA. But life in Silicon Valley was very work-centered. It's not a beautiful place. It's Northern California paved over with cement is the way I'd describe it.
Right.
But everyone wonders, why does this occur? Why did the technology center of the world occur there and why is it so difficult to replicate everywhere else? The simplest explanation for some of it is the proximity to Stanford University, which was from Manhattan Project and other Department of Defense initiatives in the 40s and 50s that set everything up and paved the way for Hewlett-Packard and the Fairchild Semiconductor. And then from there, those companies grew. The size of the universities grew. Berkeley University developed. So what you have is temperate weather, fed by talent from the universities. The university, it could have been anything, art history, it could have been finance, it could have been MBA programs, but they decided to produce an adequate number of computer engineers. And that's another factor there.
So I know there are a lot of interesting things that we all want to learn about Apple and how do they manage to make such robust and clean products at scale. And moving on to that, backstage we talked about a little bit like it's in Silicon Valley, you just hop over the fence and work for another company. Was it really like that, like moving from NVIDIA to Apple? What was the one thing? What was it like, and also what was the motivation behind going to Apple?
Well, the motivation going behind Apple is I saw the first iPhone and said, that's the next leap in computing. I need to work on that. How to get there, that was a slightly different process. But really, what Silicon Valley is young engineers fed from universities, not just from UC Berkeley or Stanford University, but really from around the country. I was recruited from Cornell University. They live and work together, and I suppose the way to describe it is there's an informal social network there of people with past work experiences, so you know everybody by reference, you have a common background, you have a lot of common projects that often relate to the next step, and I suppose the way to describe it is kind of like you have a fence. Viennsata, right? And there's a group of people and the fence kind of moves around, and then you have a different set of people that you used to work with, and the name on the fence changes. Right. So when I go to Apple, hey Vic, how's it going? I remember you from Silicon Valley, Silicon Graphics or something. Oh hey, yeah, that was a good time at NVIDIA or something like that. So it's just it's an informal network of like-minded people looking to work on. Well, when I say like-minded, it's very more like work-minded people.
Yeah,
They're not really very like-minded at all.
Keen to build products.
Work-minded, like-minded in the sense that they want to work on something new. They want to invent things, and they want to be the first people to do that.
So what it's actually like to be working on the iPhone?
Well, iPhone, Apple, I will never talk about product details, ever. Certainly not on a recorded line. But I can just describe firsthand that it was a culture of secrecy, and when you're making something new, having a 6-month edge or a 12-month edge over competition that would clone you, that's a big deal. So I worked in the original Macintosh building in Tony Fadell's division there, starting with the 3rd iPhone to the 6th iPhone. I was there for about 6 years, and unlike the open offices that you kind of expect to see in Silicon Valley, where everybody's happily chatting all day and all the privacy is gone and they're all bunched together in a beautiful room, it's really more like solitary confinement. At a Hardwell office, you can drive by the building, you can see the individual offices. You have a window, you have to put a paper up in front of your door. Nobody can come in to see the products that you're working on, even in your own building, because within the building often people work on different projects and we're not privy to knowing about other projects. So there's a culture of secrecy there. You felt a little bit, that was some of the appeal, I would say. You felt a little bit like you're in Mission Impossible, right, doing something that nobody else has done before, and you can't show it to anybody because kind of if you do, you don't work there anymore. I can comment that there was an entire division devoted to stealth cases. Since they had to be carried outside of the building, and there's some infamous stories about lost iPhones, there was a division dedicated to making the next generation look like the previous generation. So say you had a larger iPhone in iPhone 3, you're putting out the iPhone 4. This is a long time ago, but that's when they dedicated all the secrecy to these products. They built a rubber case with, sometimes it was rubber, sometimes it was plastic with screws. That was the same size as the other. It looked the same, but when you unscrewed it, it was a completely different product. Because the secret details were the level of miniaturization in the next generation.
Can you talk about a bit about you hear these stories about engineers working 20 hours a day, coming in on Saturdays and Sundays to keep that 6 to 12 months advantage alive, and is like when a release is coming up, is that something that actually happens, and how was that?
Yeah, that's like for decades. That goes on. If you're in the product pipeline for something that's shipping, you don't want to be the person that stalls an operation that ships 200, 300 million units a year. You can't be that person that makes a mistake. Just imagine you're the one that, I don't know, something as simple as making the sound too loud. You break the speaker on 0.5% of 200 million. That's enough to fill this room, right?
Wow.
If you think about the scale of things. So you definitely did not want to be in that line of sight or draw the attention of Steve Jobs there. So, and I did have one case like that. There was something I worked on that needed to be solved immediately. 10 directors and 1 engineer are on the problem. And to solve it. But yeah, that's just the way to get things done. But regarding the work hours, yeah, that's the way it was. The culture really is to keep the employees on campus at all times. There are a lot of reasons for that. One of it is, yes, to get more work hours out of them. The other one is just secrecy. Most of these successful companies, all the ones that I worked at, they invested heavily in community. One of the employee expenses that the finance department often looks at is subsidized lunches. They go, on the chopping block, that has to go. But Jensen Huang was adamant about the NVIDIA Cafe. Likewise, Apple has their own Apple Cafe, and they went so far as to build a separate cafe that only badged employees are allowed to enter. Mm-hmm. And the purpose there is you go, you eat, you have coworkers, and you discuss new ideas. Maybe there's some problems at work. We can't say that all the conversations were really about work. Sometimes they degrade into politics or somebody watching some 13th episode of a series. You try to move away from those and make your lunches inventive and functional. So a lot of patents were generated in lunchtime conversations. But also, if you talk about products and you talk about work, you cannot be within earshot. So going to nearby Mountain View or outside to Cupertino for lunch, you have a lot of people that listen. And you don't want to be the one responsible for a product.
So you told me stories about engineers working on things, achieving something that they don't even know what it's gonna be put into.
Oh,
and
yeah.
like one thing that's fascinating in itself, but then also who are the people who kind of see the big picture, how it's all gonna come together? And we also let's talk about those two things, like having to work on something that's very particular and you don't even know what it's gonna be put into later on. And then also, why do you think Apple is so good at also putting it all together then, even with this secrecy, which essentially inhibits the work in some sense?
Yeah, it does inhibit the work. Well, in many cases, there are products that will never see the light of day. They want to prototype them, build them, never really sure. There are some that I've seen, I'm not going to talk about, that 10 years ago may still come to fruition. But mostly they have to solve very simple problems in the beginning. And if it's a new product category, that's ultimate secrecy. So one example that I can talk about is a shipped product is the Apple Watch. At the time, nobody knew about the watch. We knew we were hiring for some sort of wearable. hiring for algorithm engineers. So I worked on those types of things. But for one of them, I suppose an example would be the watch. Into my office, bring in a board. There's a hump in the middle, and there's a black cloth over it, and 2 wires coming out, and I have to develop the sound system for this thing, but I'm not allowed to lift the cloth. So I agreed to that. I never lifted the cloth, never asked any questions.
Fair.
That's one story.
I wonder who's the person who gets to lift the cloth and understand everything, how the product comes together. Because there's also another thing that you told me that was mind-boggling to me in a way, but it makes sense. That Apple actually had made products that were profitable, but like even like the shipping costs, like it being like something big or heavy, the shipping costs from wherever it was manufactured didn't make sense. And when you're at this scale, you have to think about all the pieces, even like things in logistics that don't seem immediately relevant to the product.
Well, that's true. So I suppose an example of that would be Apple HomePod. You see it today, but it could have been 10 years earlier.
Right.
At the time, shipping around a heavy product cuts margins. Apple doesn't ship on products with margins below 30%. They target 40%. Software is, of course, far above that. But when it comes to hardware, it's a profitable company, and hence the success of the company. Something like shipping around a heavy speaker, and if they're not able to sell it at a high enough price, there isn't adequate profit. It's not that it can't be made profitable, it's just that they don't make enough. So it doesn't happen. I suppose what happened with the Apple HomePod speaker is enough was added to it, voice recognition, and a bunch of other useful functions that allow them to sell it for, I don't know, you pay a lot for that. So.
Yeah. So, growing up in the state of New York, going to university there, and with all the Silicon Valley attraction there, that makes a lot of sense. Moving to California. Since we have a few minutes left, I wanted to ask, like, why the move from there back to Latvia?
I have to say, in the Latvian diaspora in the United States, the fantasy was always to return to Latvia. Latvia was the golden place. They lost everything, left everything behind. So my grandparents pined, or I should say my grandmothers, because my grandfathers, one was killed before he came here, and the other one died rather early. They always wanted to return to Latvia. Latvia was their home, their place. My family tree, I find them all here.
Right.
I found all the cities and all the church records. They want to return, so I share their fantasy. Some were able to reclaim some property and live here, but if I look at one point in time, it would be with Davis Sixnants. In 2013, I was working at Nest Labs Google at the time, and I met him, and he's a super connector. That's how I would describe Davis, and he made a case for my returning to Latvia, gaining citizenship through my father, who was a Latvian. My parents are Latvian citizens, but I actually started the process through my father. Without him, I don't think I would be here, or I would be here much later.
So what are the plans now here in Latvia? Anything interesting overall in general, but also in the engineering and tech space?
Well, I'd say overall, what brings me to Latvia? Šie mani dzimte. Šie mani cilvēki. So, despite my not growing up here, never being here, I, in some way, feel like this is the place I was born in the wrong country, is I suppose the way to say it. But what am I doing here? I do have some personal goals to pursue and achieve. Beyond that, I would like at some point to start a high-tech company. I did pitch one great idea to Tesla about machine hearing, but they wouldn't let me open a Latvian office just yet, so I'll probably have to start that myself. And other things are work on some of Europe's problems. They're not unique to Latvia, but I would work on them in Latvia. Demography, encouraging to increase the birth rate, provide economic opportunities here through jobs. If I have with more children, they would need some place to work in Latvia as well.
Yeah,
so
exactly.
I'll have to start an effort there. So my contacts are still somewhat fresh. Suppliers, large corporations, whatnot. Maybe I'll have some success here as well.
I can't wait, honestly. Thank you. This has been really fascinating. Thank you. Namaste.